Kia ora koutou. My name is Zoe, and Manaya just gave a great introduction to dispersal, so hopefully I can build on that. So I'm going to talk a little bit about our work that we've been doing monitoring the post-release dispersal of toutouwai translocations, particularly in how we can address habitat use in connected sites. And so this is research we've been conducting with Doug Armstrong, Kevin, and Cara McDermott. Before I start, just want to thank a lot of the stakeholders that we've had involved in this project, particularly Tānaki Maunga project, who have been very supportive in our research on their maunga, and also Palmerston North City Council and Rangatane for our Turitea site. Right, so connectivity and reintroductions, as I said, Manaya's talked about the long-term benefit of connectivity for species dispersal. But for reintroductions, it's a bit of a challenge. So New Zealand has been in the past pretty good at doing reintroductions and translocations, particularly to islands where we can put birds, we can eradicate pests, and they can't go anywhere. However, in the mainland in New Zealand, we've had much lower success rates, and we still have quite a high failure rate for translocations. Part of the problem with these mainland sites is they're highly connected, and so individuals can move everywhere. They're very hard to manage. We often can't completely eradicate our pests, so we're generally dealing with sort of low pest densities at the best. And so we have this great dispersal potential. Individuals don't necessarily stay where we put them. They don't see our invisible lines of where a management area is. And so they'll likely can move quite easily throughout the landscape if it's not fragmented. And these sites are really difficult to monitor. I mean, I'm sure a lot of you know about trying to do monitoring in these large landscapes. And so because of that, we don't have a lot of information or data on translocation, what influenced the outcome of a translocation, and whether it was about mortality rates to do with predator control or dispersal related. So this brings us to a question of how large do we actually have to manage these areas and connected landscapes to protect those dispersing individuals, particularly at the early stages of a translocation when we have a small population that's highly vulnerable to being lost before it gets established. So quickly, I'll just mention how dispersal does impact translocations in these connectivity sites. Firstly, if we choose a release site here on the right, we have a small or large-ish area of managed area, about 600 hectares, and you've got the managed area in the middle there. And we've decided to put some species back, some toutouwai, and when we release them, they go through a post-release dispersal phase. Birds get quite stressed out by a translocation. They don't know where they are and need to figure out where they want to go. And so during this period, we might lose a few individuals that go outside our managed area. If we're lucky enough to have a few hanging around in our managed area, we might have those day-to-day movements in home range territory, dispersal patterns. And again, if that takes us outside of the managed area, we're going to lose those individuals to those predation threats, which might reduce our establishing population size. And finally, we get this juvenile dispersal or natal dispersal. And this is quite a big movement that birds undergo. And so a lot of these juveniles might disperse further than adults, and they might leave our management area. So this can lead to low recruitment into a population. And if at any of these stages we get too many individuals dispersing outside of our management area, we're going to get a failed translocation. And this is what happened at this site, which is Hunua Ranges. So yeah, dispersal can really impact our reintroduction success. So trying to figure out how we can improve our outcomes is really important. And so what we've been doing is we've been monitoring a few translocations into these sort of larger connected areas to try and track individuals and see how many of them are dispersing, how many of them establishing, and what that means for management. So our first site that we've been working on is at Turitea Reserve, which is just outside of Palmerston North. It is the main water catchment for the reserve. So in here is some reservoirs, and it's closed access to the public. It's about 2,000 hectares that is intensively managed. You can see each of these dots here is a DOC 200 trap, and each triangle is a bait station. So it's a pretty good network of predator control, and from this they've been able to achieve a sort of average of about 20% rat tracking rate for the last 10 years or so. So it's quite a great result for the reserve, and because of this, we've got to the stage where they could potentially reintroduce species. But the problem with Turitea is it's fairly connected. It's at the northern tip of the Tararua Ranges, so totally connected to that Taurua Ranges and forest to the south of the North Island. So there was a bit of uncertainty about how many individuals, how many toutouai would be able to disperse outside of this managed area and how much would establish in the reserve. But we went ahead with a release in 2020. So 40 toutouai were released just in the central part there at the X. And we undertook some pretty intensive monitoring across this reserve, tracking birds with radio telemetry and drone telemetry, and also just breeding monitoring to see what happened in this larger site. So what did we find? So during the post-release dispersal on the left, every point here is a location that we detected a bird over the 12 weeks of monitoring that we were able to do, thanks to the battery life of the transmitters that we had on them. And so we got a fairly good coverage of birds. We managed to track about 30 birds across the 12 weeks. And at the end of the 12 weeks, we knew that there was at least 25 birds still in the reserve. And they covered an area of about 1,300 hectares. So it was a fairly wide area, but it also was fairly contained within the reserve. And we think that this might be contributed, the topography of the site might have contributed to this sort of limited dispersal, particularly in the southern area where we get higher ridge lines and the vegetation starts to transition to sort of more subalpine scrubby forest. So we think this might have restricted the movements into the more lower areas of the reserve. Where they actually established, so we came back at the breeding season a couple of months later to see where they actually established, and we had about 20 birds established, so about a 50% establishment rate in the reserve, and they actually only established within the sort of core area of about 200 hectares around the reservoirs. So if you look at the dispersal versus the territory areas, there's quite a big difference. So in terms of understanding what movement patterns species do after release, if you're only relying on breeding monitoring, you might not get a full picture of how far these birds are actually moving. Here's just a few examples of individual movements, because trajectories are fun maps to look at. Some of our birds moved quite a lot. So this is a pair that established on the left, and we had a couple of our individuals with our biggest dispersing records that we observed. So this female here moved about 4 kilometers, and she did that in a single day because we observed it there, and then we observed her back in the main area the next day. And so the male also did a bit of an explore around the reserve before they settled in their final territory in black there. Another pair didn't move quite as much. They actually kind of stayed in that sort of central area and didn't move too much. An interesting thing that we could see with the trajectories is that often the females, you can kind of just see here that the females would visit all the other locations that other males were starting to establish territories before finally settling with their male partner. And they also settled a bit later than males. So the males would set up first, females would visit them all and then figure out who they wanted to be with. And then we have another that had a little bit of back and forth, and again, finally settled in the center there. So these are really useful to be able to influence our management. We can kind of get a sense of how far they're moving and where our management might need to be focused. In terms of how long it actually took them to establish, we were able to take all our observations and do a segmented regression model to kind of predict when the shift from a dispersal phase to a territory establishment phase was happening. And so in this graph, you can see the days since the release on the x-axis, and on the y, we have the accumulated distance traveled. So that's if you add up all the different stops that they were taking, how far they actually dispersed over that time. And first off, you can see that some birds really dispersed quite high. We had a couple of birds that dispersed over 20 kilometers before they settled their territory. But our model predicted that we had a bit of a phase shift around 50 days following release. So that first 50 days was when birds were kind of freaking out, figuring out where to go. And that's when they were dispersing and had quite a lot of movement. Whereas after that 50 days is when their movement started to slow down and they established their territory. So all these points that have not moved is when we know that they've settled and they've established their permanent territory and haven't moved. There's a little bit of movement at the end as we had a little bit of pair swapping towards the end of the season. One interesting thing is, so at Turitea, we had about a 50% establishment rate at the end of the breeding season, but if we actually look at when they they were predicted to start settling down, we still had about 72% of the birds remaining in the reserve. So if you think about managing post-release management of a release site, you might be able to be strategic about your predator control, and if you can kind of really hone in on that 50 days, potentially you could increase your establishment rate then rather a bit more. What we were able to do with that dispersal data and breeding data is we were able to create some species distribution modeling. So this is a technique of using sort of machine learning to predict the habitat use based on presence and absence records, and then we can fit that across a range of environmental variables. So we used about a dozen environmental variables across the site at a fairly high resolution. That was about 5-meter resolution. And we were able to use the dispersal observations to create a dispersal habitat prediction, and also then the breeding monitoring data to predict where they were actually using settling in their territories. And so you can see that they're a little bit different. So on the left, we have our dispersal, which is really highlighting that central area again, but also they were dispersing across a larger area of the reserve, but not going into that southern area, which might be that vegetation shift to more higher elevation. On the right, the breeding habitat was highly constricted to that lower regions around the reservoirs, where yellow is the highest probability of that being a habitat for breeding. So this was is really a useful tool potentially for helping to identify where we might be able to manage, particularly for a species like toutouwai that might be able to benefit from slightly different management regimes between a dispersal and a breeding habitat, breeding phase when they're more vulnerable on the nest. If we actually look at the environmental variables that were contributing to those models, here we have all the environmental variables that were selected in the models and how much they contributed to our models. So as you can kind of see, that water deficit was a really important variable in why toutouwai was selecting a habitat in both our dispersal and territory models. Basically, they like the drier areas. Turitea is a very wet site. It's a water catchment. It's pretty wet and soggy on the ground, and they were selecting the slightly more drier areas. For their dispersal models, they weren't going very far from the release site, so kind of matches Manai's work as well. So we had much higher probability of them selecting within that sort of 1,000, 2,000 meter area. And then they were also liking to stay a little bit closer to a forest edge as well. For their territory establishment, they were a little bit more influenced by the slope. They didn't like the steep areas, so something they have in common with me. Gentle sloping areas are much nicer to hang around in, and they also liked being close to the reservoirs or a water edge. So there was a little bit of a difference, but overall they were quite similar. And for the breeding habitat, it was basically a much stronger preference for the same variables. So they were a little bit less fussy when they were dispersing, but when it came to settling down, they really honed in on these particular environmental conditions. And what we've been able to do with these models is actually help improve or guide the management at Turitea. So we know that during their dispersal phase, toutouwai aren't quite as vulnerable. They can survive a little bit more rat pressure. So across that breeding, predicted breeding range, we've been able to increase our predator control, so that each of these crosses is a additional 80 to 20 trap that has been put out to give a bit more buffer around the core area. Whereas in that core breeding area where we know females nesting are highly vulnerable to rat predation, the team there has increased their amount of bait deployment. So these are striker baits that have been deployed within that area. But Cara will talk about this a bit more later this afternoon, so I'll leave that up to her to expand on more. So our other site, Taranaki Maunga, so they had a reintroduction of toutouwai in about 2017 and 2018 at their A24 block. So this is the block on the right, and it's about 1,000 hectares of intentionally managed forest, mostly by A24 traps, the resetting rat traps, which are on a fairly good high interval grid line. Each of these white dots here is a trap. And so this 1,000 hectare block is highly connected to the remaining maunga. It's of the 17,000 hectares of forest. So there's pretty high uncertainty about how much dispersal, how many individuals would stay, and it's a smaller area than Turitea. So was it big enough to actually support enough birds to establish and account for any dispersal outside of the maunga. With their trapping grid, they've been able to achieve an 8% rat tracking rate, particularly in the core area of the grid. It's a little bit higher around the edges, but it's pretty good for a connected contiguous forest site. Highly connected, and they released about 95 toutouwai, so more than in Turitea. And since the release, they've been undertaking about 6 years of post-release monitoring, only in the breeding season. So they've got some really good data on breeding monitoring, which we've been able to use to do some population models, which Doug will talk about, and also try and come up with habitat use and dispersal information as well. So in terms of what happened after the release, so here you can see in 2017 and 18, we released the 95 toutouwai, and there was a couple of 1080 drops that happened in the block as well. So the green line here is the prior model, or the predictions of what would happen with the breeding population, and the black dots are actually what happened. So this is the estimated breeding population size following release, and you can see that the population grew really nicely in the first few years and really followed the prior prediction. So that was a great sign, and not a very high establishment number, much lower than Turitea, so around the less than 20 birds actually established, which could be because it's a smaller site with that really high connectivity. But enough birds did establish to actually start breeding and growing that population. However, we took a bit of a turn after 2020, and the population started going downhill a little bit. There was a few issues. COVID appeared around this time, and there was a few issues with getting the A24 traps reset. I think there was a year when they weren't reset, and also a delay in the 1080 follow-up drops, which was supposed to happen in 2021, and I think were only happening this year. So there's been a bit of delay in 1080. And so I don't know, Susan, if this is following your rat bounce predictions, potentially. But yeah, so we had this decline in population, which wasn't a really great sign. And we wanted to do something about it. If we actually look at what that meant for the population growth, so these are predictions of lambda, or the finite rate of increase, which Carol will talk about more. So I'll briefly just show what we could do. We updated our models, and so prior to the 2020 drop in population, we had a growing population above 1, but after 2020, we were predicting a much lower population growth, well, a negative population growth of 0.87. So it wasn't looking good for these toutouwai, and we needed to do something about it. One of the problems was that there wasn't any rodent monitoring that was happening after 2020. But using some of the past research by Doug and his colleagues, we could predict what might have been happening with rats in the site. So here we have the relationship between the finite rate of increase and rat tracking rate. And the blue line is what we predicted what we predict will happen at Taranaki. And so here is our lambda of 1, which is so positive growth above, negative growth or decline below. And this red area is where we start to get a decline in population. Here we have our black line, which was our updated lambda of 0.87, and we can kind of start to predict that our rat tracking rate at Taranaki is probably up at the 76% mark, which is about similar to what tracking tunnels outside of the block show for the maunga. So rats have basically predicted to have returned to what they would be without predator control. So not great for a bird that doesn't like rats. From that, we can predict what might happen to the population if we don't do anything, or if we can get management back to the same conditions. So the blue line on the right here is what we might expect the population to do if we can get management back to whatever the conditions were present in prior to 2020. And the red line is what might happen if we continue on the path of what has been happening with delayed 1080s and issues of getting the traps set. So without doing anything, population was likely to decline and potentially go extinct in the near future. Whereas if we can get back to what the previous management was, we might have a chance of rebounding that population, which hopefully will happen. The 1080 drop is planned for this year. So hopefully we can get things back up and running. using the breeding monitoring data, we've also been able to predict the breeding habitat use on the Maunga, so potentially help guide future management and expansion of their predator control. And here on the left, you have a habitat probability map for toutouwai across the whole Maunga. And interestingly enough, you can see that where the block is on the northeastern side, it's actually in this kind of little isolated patch of habitat compared to the southern area where there seems to be quite a lot of predicted breeding habitat present. And if we look at the variables that were important for those for this model, is very similar to our turatea models as well. So water balance, Taranaki is an even wetter site than turatea, so there was basically no water deficit across the whole site. So I had to use a slightly different water variable there, but it's basically the same thing. Drier sites were more selected. They liked being not too far away from the forest edge, lower sloping areas, and distance to water didn't have too much of an impact, except for at the very close to water. They didn't like being right next to a river, but they would be a little bit further away. So these sorts of tools are kind of hopefully really helpful for influencing ongoing site management and potentially helping to be more strategic about where we can do predator control, especially in these really large connected habitats where we can't do 100% control everywhere. Zooming in on our block, here is all our toutouwai locations in dots, and you can see that habitat use. And just from the breeding monitoring data, the team there had already noticed that toutouwai weren't really using the upper parts of the block. So they were already thinking about potentially changing the layout of the grid to support more toutouwai across those lower slopes. And using a species distribution model that we created, potentially this northern area might be somewhere that would be beneficial to expand to. And then finally, we during our project, we had tried to get some juvenile dispersal. As Anne said, there's really not a lot of juvenile dispersal data for forest species. I tried to track a bunch, and it was very hard to monitor them. Of about 20 birds that we tried to track in Taranaki, I only got one recruit into the A24 block. But the benefit of having these sorts of translocation programs that have really good ongoing monitoring is we can start to get more juvenile dispersal data from those monitoring programs. And so on the left here, we have a couple of recent locations. This is just from the last few weeks ago, of two juveniles from this last season that dispersed about just 1.5 k's away to form a territory. And the really great thing about having this data is we've been able to use it to kind of validate our habitat models. And so far, all of the juvenile dispersal points that we've been able to add to the database have been consistent with our habitat models for both the breeding models and the dispersal models, which makes me feel quite good about my models. But it's also really great to show that any management that we do based on these models might be quite reliable for future dispersal patterns. And then on the right, we have one from Taranaki. As I said, we've only had one bird actually juvenile recruit into the population since we started tagging birds, but we have had a couple outside of the block being picked up by rangers. And so this was an individual that dispersed about 3.5 k's away. And we know from other sightings as well that birds can disperse as far as 10 kilometers away from the block. So again, that really high dispersal in Taranaki is having a bit of an impact on recruitment for this population. Yeah, so just wrapping up, what has the post-release monitoring told us? So that sort of 1,000 to 2,000 hectare size in these connected habitats might be large enough, especially if you can account for topography that might be able to be used to reduce dispersal using ridge lines for species that don't like going up ridge lines. But we get back to the problem of, can we actually effectively manage these areas? And it really requires quite a lot of effort to get our predator control or predator numbers down to the level, especially for these more vulnerable species. Species distribution modeling might be effective, useful tools for improving outcomes and guiding management, but they really rely on good quality monitoring data to inform them, and ongoing monitoring to make sure we can validate them. Yeah, so I think that's me. So thank you for listening. Hopefully I was okay for time there.
Excellent. Thank you, Zoe. That was a wonderful talk.